we're given that side AB is congruent to side CD, and so notice I've already got those congruences marked on my drawing. We're told that side AB is parallel to side CD, and so I've already got the parallel arrows in there, right? And what we're trying to prove here is that triangle ABC is congruent to triangle CDA. Okay? So see if you can't crank out a quick strategy for this. Even if you're just, maybe it just means copying the picture down and marking up the picture with the congruences that you see, and then we'll write the steps down together afterwards. But come up with a strategy while I take roll. Okay, let's have a little look here. So, suggestions. Maybe write down the given first. Let's separate these into our statements and reasons, and we always start off, don't we, with the given information, so we know. Now I'm going to write this down like I would in Moodle even. So we write this as Step 1, side AC is congruent. Anybody remember the shortcut for congruent? All 240, yep. Side AC is congruent to side CD, and then let's also add in there side AC is parallel to side CD, and my reason is just given. Okay, so there's step 1. What about step 2? What else do we need? What do you think? Yes? Okay, good. Angle, good. BAC. Let's write that in. So BAC is congruent to angle, say it again? DCA. Okay. And if we want to, notice that I've got a 1 there, which means that's kind of a short way of saying the angle. So we could even say angle 1 is congruent to angle 2 if we want to take a little shortcut. Perfect. There's our statement. Now let's get a reason down for that. So angle 1 is congruent to angle 2. What's our reason? Yeah, good. Alternate interior angles, right? If we extend the angles, or extend the sides a little bit, just got a bigger version of this drawing. Look what happens here if I extend the sides. So this guy and this guy. And then if I extend this transversal, well, isn't that just 2 parallel lines cut by a transversal, right? And so then those are just alternate interior angles, aren't they? Opposite sides of the transversal inside the 2 lines, right? So very good. So by alternate, and I think I can just, well, by alternate interior angles, that's true. Okay, so now we've got some stuff. How many parts of each triangle, how many congruent symbols do you have in each triangle? 2. How many do we need?
Charmaine Robinson, come to the office, please.
So we need 1 more. Okay. Suggestion, somebody. Somebody, you contribute. Somebody else. What else? We need 1 more congruent symbol in each triangle. Suggestions. BC and AD, that'd be nice. But is there a way we can, do we have a reason for that, I guess? It's not given to us.
Because the angle 1 and 2, it's on the side AB and BC.
Okay, but that's not enough. Because this could still be, I mean, what if there's nothing to say, for example, that, what if this side, I'm just drawing a quick little picture. What if this one had gone down a little bit further this way, like that? There's nothing up here so far. Well, actually, hang on.
The angles.
Yeah, I see what you're trying to get at here. It's hard for me to explain other than to say that even though they look that way, we don't have a reason we can point to on our list that says, okay, that proves it to us. So we need something else. What do you think, Luke? Yeah, okay, good. We see that side AC is a shared side. That's low-hanging fruit. We always want to get those. Those are easy ones, right? we know that side AC is shared by each of these two triangles. Now look, if I go, I'm going to go over to my other drawing here for a second again real quick. Let's see, get rid of all that stuff. So if I do this, right, you know, once again, if I want to, I could pull those apart, right? If I took those two triangles and pulled them apart, wouldn't I get something like this if I took this guy and scooted him over here? I'm going to get something like that, A, B, C, with these congruent symbols. That angle, that side, and that side now, right? And if I take this triangle over here and separate it out to this side, this top one, it just looks like that. Right? And I've got these congruence marks. Right? Does that make sense? And so now we can see, sometimes when they're mushed together like that, it's hard to see that that is a shared side, but it is. When I pull it apart, side AC appears in two separate triangles, right? Does that make sense? Okay, now we got it. How many congruence marks do I have in each triangle now? 3. Now what's my pattern? What's going to be, is that a pattern that proves those two triangles are congruent? I walk around the outside. What's the order in which I hit those congruence marks? Yeah, side angle side, isn't it? Right? If an ant starts here and walks around this way, he runs into a side congruence mark, an angle congruence mark, and a side congruence mark. Right? Side angle side, same thing over here. Side angle side, right? Okay, so we can do that. So our statement was side AC is congruent to itself. And what's our reason for that? If something's congruent to itself? Yeah, that's always the reflexive property. Good. So reflexive property, technically reflexive property of congruence, but that's good enough. Okay, so now, and then you told me that now that we've got all that information up there, that's enough for us to prove the triangles are congruent by SAS. So our last step would just be triangle ABC is congruent to triangle CDA. And you told me the reason was the pattern was SAS. Done. How about that? Okay. Does that make sense? Okay. Now let me ask you a question. Did it matter? Steps 2 and 3. Did it have to be in that order, or could I have switched those? I could have switched them. Didn't matter, right? What those did for me, I started off with only one congruence mark, and these are the other two congruence marks in each triangle. It doesn't matter what order I make those marks. But the last step is definitely going to be the SAS step, right? That's what finishes the proof. Because that's where that's what we're trying to show, and so that's how we end up with the proof. Okay? One more. How about this guy? Take a second, so you just digest that. Trying to show that the left triangle is congruent to the right triangle. Okay, look at the stuff we have. We know side AB is perpendicular to side AD. Okay, so there's AB, there's AD. Well, that right angle sign means perpendicular, right? We know side DE is perpendicular to segment AD, and so there's another perpendicular sign. So we've got those markings on our drawing. We know side BC is congruent to side EC. Okay, so there are my congruence marks. And we're trying to prove the triangle is congruent. Okay? Well, let's just skip over to the drawing for a second. We'll come back and write in the statements. I guess I'll write in the given real quick first while you think about this. So Okay, so now let's skip over just to a big picture and we'll just mark up the drawing so we come up with a strategy. So how many congruence marks do you see in each of those triangles there? Yeah, I'm hearing two. Anybody have a different answer? I think there are two different answers that I would accept here, both being essentially right. Two words. No. Three. That's five. Four. No.
Three.
One also. Yeah. Technically, there's only one congruence mark in each triangle, right? The segments are congruent, but what's the other one? Somebody, Glenn, did you say two? What's the other one you saw? Okay, now indirectly that works, doesn't it? Because we know if angle A and angle D are right angles, what do we know about right angles? They're 90 degrees, and so they're all congruent, aren't they? So does anybody remember what the name of that reason is that all right angles are congruent? Use it a couple times. I don't expect you to. I'm just curious if anybody remember. It's on the list. It'll be on the pull down menu. It's the right angle congruence theorem, which just says all right angles are congruent to each other, right? So we have two. We actually have two. We have to give a reason for one of those. You know, we have to actually provide that reason, the right angle congruence theorem. But we have two pretty easily. How many more do we need? One. Any ideas? Where's that going to come from? Over this side of the room. Where's that going to come from? Right here, Brandon. You have any idea? Yeah, vertical angles, sure. Yeah, we got vertical angles right here in the middle, don't we? So this angle and this angle are both congruent by vertical angles, and then we said that this acts as a congruence, right? And so what's the pattern then? Now let's write down our four patterns to choose from. We can only choose from these four. What are the four patterns for triangle congruence? Assuming we're going to leave out HL for now. We haven't gotten up to that stuff yet. So just up through 4-4 and 4-5, we only have four patterns. I'll start you off. SSS, right? What else? SAS. What else? Angle, side. That's the harder one. And then one other pretty easy one. No, that doesn't work, does it? Because I could have a really small triangle and a really big triangle with the same angles, but they wouldn't be congruent. There you go. ASA. Okay? So those are our four choices. Does any of those work up here? Do I have that pattern in both triangles? Angle, side. Yeah. Everybody see that? If I start here, on the left triangle, if I start there and work my way around, I go angle, side. Same thing on the left, right? Angle, side. Okay. Make sense? So we got it. There's our proof. We wrote it on, it's all marked on that drawing. We have to just go write it down. Okay, so step 2, I guess we could say angle A is congruent to angle D. What did we say the reason for that was? Yeah, good. Right angle congruence. Theorem, but we'll just write right angle congruence. Okay, there's 2. We need one more. And that was vertical angles, wasn't it? So how do we say those angles there? Brandon, you're the vertical angle man. What's the name of that left vertical angle? Yeah, right there. ACB, that'd work, wouldn't it? So angle ACB is congruent to, how about the right one? DCE? Is that what you said? And the reason was vertical angles. Okay, and then the last step was, now we had it, right? We just said that we fit the pattern AAS. Now we can say that the triangles are congruent, ABC and DEC. side pattern. Done. How about that? Make sense? Once again, steps 2 and 3, do they have to be in that order to be a switch stick?
Yeah.
Sure. Yeah. Okay, does that help? Get the idea? Okay? All right. Well, let's go work.